Can you make anything out of this title? Anybody? No? Alright. Before that, I'm Kumar. I'm an independent security researcher, and this work is something that I do outside of my day job. Okay, so this is what I'm going to talk about. I'm going to talk about the same origin policy. Anybody here know what a same origin policy is? Okay, that's everybody. Alright, so I'm going to talk about same origin policy as a defense, from a defensive perspective. I'm going to talk about same origin policy from an attacking perspective. I'm going to talk about a kind of attack called as phishing the browser, right? And under this type of attack, there have been, legacy attacks like, when you speak, the cookie, the flash cookie, the cache, or like false feed contents. But then in this round, I'm going to talk about, some new kind of attacks. I'm majorly going to focus on Google VH. It's a new technology. I'll be discussing a lot about that. And then I'm going to talk about Flash. I'm going to show how you can use Flash to steal files from your local file system through your browser, right? And I'm going to show a tool called as Imposter, which I've written, which basically is used to do most of these attacks. So I'll show a demo of this tool wherever I possibly can. Alright, let's talk about same origin policy. How many of you here are from the web application security area background? Okay, alright. Now, normally when you're browsing internet, right, you have multiple tabs open on your browser, correct? So let's say you're connected to Gmail, you're accessing your mail, and then you're also connected to, let's say, some porno site, watching porn in between, right? So the thing is, your browser does not let content loaded from Gmail to access the content loaded from another site, right? So it goes like this. If you load something from google.com, that's only going to have access to content which have been loaded from google.com. It cannot get access to content which have been loaded from another site, right? So that's called the same origin policy, and it's actually the very base of your browser security. If you do not have the same origin policy, then all security control in your browser basically breaks down. So it basically means that if you're browsing Gmail, I send you a link to my site, you come to my site, and from my site I'll be able to steal your Gmail cookies, right? So the same origin policy basically prevents that from happening, right? So it only means that a script loaded from Gmail can get access to cookies of Gmail. So that's pretty much what the same origin policy does, and it's the very base of the browser security. Any questions here on same origin policy? Okay. Now let's look at this from an attacking perspective. Your browser, before it can give access to any data that is stored on the client side, that is in the browser, the only thing that it verifies is if this script has been loaded from the same domain, right? And if, say for example, I can load script under the domain name of google.com, then I can get access to all data which Google has stored on your browser, right? Because the browser is only going to look for the domain name. So that's where we try to use same origin policy from an attacking perspective and try to steal data that has been stored on your browser. So I'll get into details of how this is actually done. Okay, this is kind of how it happens. You can send a request. Okay, let's say for example, you're a laptop user, right? You go to an airport or you go to some other coffee shop. You connect it to a free Wi-Fi network, right? Now this Wi-Fi network can belong to anybody. Let's say for example, this Wi-Fi network has been put up by me. It has been put up by an attacker, right? So now when you request gmail.com, I can serve content for gmail.com because you've connected to my access point, right? The content does not have to come from actual Gmail. Now I actually can get access to the DOM of Gmail, right? So that's what is happening here. The victim is connected to the attacker's access point and he's requesting for MySpace or Gmail, whatever it is. the attacker is going to serve content under those DOMs. So the attacker is right now MySpace, the attacker is right now Gmail. He can serve content as any site that he wants to. Okay. So we'll look at some differences between phishing the user and phishing the browser. When you look at phishing, okay, how many people here know what a phishing attack is? That's all. Okay. Phishing attack is something where I send you a link, saying your bank account has expired. You click on this link, and you click on this link. You're taken to a site which looks like your bank site. You put in your username and password, and the attacker steals this information. Now, why does the user put in the username and password? Because he feels that the site looks exactly like the bank site, right? So that trust on the look of the site, leads to him giving away the data that he has with himself, right? Now, in case of phishing the browser, what we're going to do is, I'm not really going to ask for data from the user. I'm going to ask for data from the browser. And what does the browser actually believe in? It believes in the domain name, right? So if I can load content as google.com, and if I'm going to ask for content as google.com, then your browser is going to hand over the data to me. So these are some like nitty-gritty differences between the two types. I don't think you will probably have to go into this. Now, there have been discussions of similar talks in the past, where you use such attacks to steal cookies from the browser. Say, for example, if you've gone to Gmail and a Gmail cookie has been set on your browser, I can load, if you're connected to my access point, I can load JavaScript as gmail.com and I can get access to this cookie. So I can do things like stealing cookie, I can set cookie, I can steal your Flash cookie, they call them local chat objects, I can set local chat objects, I can steal cache files, I can poison cache files, and you all might be using Firefox, so every time you fill up a form and you click submit, it will ask you if it wants to remember this username and password, right? So if you let Firefox remember this username and password, this data is stored in Firefox, it's stored in the browser, right? And I can steal this data from the browser directly without you even coming to know about it. So these have been some attacks in the past, and in fact, Metasploit can do stealing cookies and stealing formula. It's got like inbuilt plugins to do that. So what's going to be new? What are we adding to the table in this talk? All right. So we're focusing on a new technology called as Google Gears. I mean, if you look at it, it's actually not that new. It was launched in early 2007. Anybody here heard about Google Gears before? Okay, you heard about Google? Nobody? Nobody? Wow, okay. So what do you use? Bing? Alright. So Google Gears was a technology which was launched by Google in early 2007. So it's almost like 2.5 years now, right? And the primary objective of Google Gears is to enable offline functioning of websites, right? Now we'll see how this offline functioning of websites is enabled by Google Gears. But then Google Gears is a very popular plugin. It's used by some of the most famous sites: Gmail, Google Docs, Google Reader, MySpace, WordPress. All of these sites are using Google Gears. Anybody here has used Google Gears? You have? All right. Anybody here has used Google Chrome? Chrome? Yeah. Right. Chrome has Gears inbuilt, right? So you guys are all, whoever is using Google Chrome, have all used Google Gears as well. It's just that you don't know. Okay. Now let's, before we talk about how we attack Google Gears, since most of you are new to Google Gears, we'll just talk about what exactly Google Gears is. Google Gears has two primary functionalities. One is database, the other one is local server, right? Now database is a client-side database. Now I said before that Google Gears' primary objective is to enable offline browsing of sites, right? So Google Gears has a module called a database, which creates a database on the client side, that is on the browser, right? It's a SQL-like database. So you can like run normal SQL queries from JavaScript, and you can insert data, read data, change data, delete tables, create tables. Anything that you would do on a relational database, you can do it on a client-side database, right? And yeah, so and the other one is local server. Now, local server is, okay, let's say for example, I want to access my Gmail offline, okay? So it's one thing that I store all my mail content in an offline database, but then I actually need some HTML and JavaScript to fetch the content and show it to me, right? So I need to have pages rendered to me even when I'm not connected to the internet. So that's why local server runs. Local server is like a web server which actually runs on the client side, right? So using local server, if a site stores, let's say for example, index.html, if Google is going to store index.html in local servers, every time you request for gmail.com/index.html, the page is fetched from the local server. The request does not go to gmail.com. It comes from your Google Gears, right? So even if you're not connected to the internet, you will still be able to access that page because it is actually stored in the local system. And again, like setting these files is. You got a question?
Yeah.
Yes.
Our local server caching is different than browser caching.
It is completely different because browser caching is there for performance. It's there from a performance point of view, right? But this is very intentional in the sense that you explicitly say that this file is going to stay on the client side, and after that you clear your cache to do whatever you want to do. This file is actually going to stay on the client side. It's not going anywhere, right? It's not like your cache it expires after some time, or when you clear your cache the page it goes away. It's not like that. Okay. So you can pretty much store any kind of file that you want in local server. JavaScript, HTML, images, Flash, it can be anything. Okay. Now I told you what is the functionality of these features, the database and the local server. Now there is a lot of sensitive data which is stored in the Google Gears database. Now the only thing which is controlling access to this database is the same origin policy. Which means that if a database is created by Google.com, only script loading from Google.com can have access to this database, right? So Google is completely counting on same origin policy to secure the data which is on the client side, and same goes for local server as well. Only JavaScript which loads from Google.com can set or delete a page in the local server of Google.com. Right, and as we discussed about earlier, in case of you connecting to my Wi-Fi, I can be Google.com, right? So I can read content from your Google Gears database, and I can set files on your local server. Did you get the idea? So that's what the whole attack is about. So the kind of things that you can do is in terms of databases, you can steal data, you can set permanent backdoors. I'm going to show a demo of stealing data. I'm going to steal the inbox of a Gmail account using my tool. And for permanent backdoors, I'm going to show you an actual 0-day on MySpace. Alright? And in terms of local server, what you can do is you can steal sensitive pages. Like if the server has already cached pages on the client side, you steal those pages, and you can set permanent backdoors on sites. So we'll see how all of these things can be done. Alright, so this is the explanation of the database part, basically saying that if the database is created by example.com, only JavaScript loading from example.com can have access to the database. Alright, the thing is, I told you that if a data is stored by google.com, right, and when you connect to my access point, I can become google.com. Now there's a small problem. If the database is created by https gmail.com, then I cannot become https gmail.com because I do not have the SSL certificate of Google, right? So that's a big problem, and I think all of you would know that Google uses HTTPS by default now, right? You create a Gmail account, you try to log in, it's HTTPS throughout by default. But there is a catch. If you are using offline Gmail, right? That is if you enable Google Gears for Gmail, and if you're using the offline functionality of Gmail, then all your data is stored on HTTP. It's not stored on HTTPS, right? And all your Google Docs, again, they're stored over HTTP. Your MySpace, it stores all your private messages using Google Gears, and again, it's stored over HTTP. So, in reality, there are like very few sites which actually use Google Gears, and they use HTTPS to store and retrieve data. Okay, so this is an example of how the database creation actually works. So this is like these are the APIs. It's all like JavaScript code. You create a Google Gears database object, and then you open a database, and you have to give a database name. Now the thing is, let's say for example, you connect to my access point, and I need to read all your Gmail, all the content that's stored in your Gmail account, which is actually there on the database, which is on the client side. Now, before I can read this, I would have to know the name of the database, right? Now, Google has made it a little difficult. What they do is, they create the database in the name of the Gmail account, right? So I cannot just go about stealing database of any random person. I must actually know the person's email ID, before I can open this database and I can steal this data. But in case of MySpace, they're using a generic name for the databases. It's always MySpace or messaging or database. So I can have my tool running in like a Wi-Fi spot. Like people just connect and they leave. And I'll be collecting all the MySpace inbox messages. I don't even know who those people are, but I can still collect it. But in case of Gmail, they made it harder. I must explicitly know what the email ID is, before I can do my attack. So this is an example of this is actually supposed to be here. I don't know when it will end. But anyway, so this is actually my, I'm trying to show the Google Gears database, right? So this is the database and this is the gear. Anyway, so this basically shows a person sending a request to Steve_DB, and like this is the JavaScript to actually read data from the person's local MySpace database and send it out. It's not clear here. Okay, now let me just show you a quick demo. I'll show you a demo of getting contents of the Gmail inbox, right, using my tool. So ideally what would happen is, like I would have two systems. Like I'll have my attacker's machine and I will have a client's machine both connected over Wi-Fi. And since like we don't have all the setup here, and what I'm going to do is like I'm going to be the attacker and I'm going to be the victim. Like I'm going to play two roles. All right. Any questions so far on the concept of gears or like this?
This is using HTTPS.
Currently,
it was with SSL strip. Currently, it was with SSL strip and
you can, but the thing is you don't actually need to. Because your normal Gmail uses HTTPS. Right? But then when you have enabled Google Gears, that is when you have enabled offline Gmail, right? All the data is stored over HTTP. So you don't actually have to go that far. Google itself is using HTTP and Google Gears. Right? Any other questions? Okay. Alright, so I'm sorry? Google? Yes. Only for Chrome? No. Gears is a plugin for all browsers. You can install Google Gears for Firefox, you can install Google Gears for Internet Explorer. If you're not installed Google Gears, you're not vulnerable. Even if you've installed Google Gears, you're still not vulnerable unless you have specifically enabled Gears for that site. Right? You have to say, okay, in Gmail, you've got an option. When you go to your settings, you've got an option saying, enable offline Gmail. If you enable offline Gmail, that's when Gears actually comes into the picture. Unless you do not enable offline Gmail, you're safe, right? It's the same way for other sites as well. In case of WordPress, it uses Google Gears. Again, you have to go and enable it. It's going to ask, hey, you've got Google Gears installed. Do you want to enable this feature? It's going to make it fast for you. So if you click on enable, then it's going to get enabled.